Hello, and now we are slowly approaching towards modern classification. It's first started with Henry Moseley. In the year of 1913, 1913, he was analyzing the X-ray spectrum of elements in the University of Manchester. What is spectrum? Spectrum is the segregation or separation of elementary light from the mixture. For you might have seen rainbow. You have seen that rainbow, there are 7 colors. These 7 colors are from white light, which is segregated or separated. So he was doing analysis of X-ray spectrum of elements. In some of the future topic I will discuss about what is X-ray spectrum. And he found that X-ray spectrum depends on nuclear charge of an atom. And just it will be relevant if I talk little bit here. In the year of 1920, Rutherford, another scientist in the University of Cambridge, he identified that this nuclear charge is actually same as atomic number, which is same as the number of protons. So there is a relationship between the X-ray spectrum to the nuclear charge to the atomic number. And Henry Moseley found that there is a fundamental quantity which increases at regular steps as we pass from one element to the next. So as we move from hydrogen to helium to lithium to beryllium to boron, there is a regular change at a regular interval on the X-ray spectrum. And he was able to draw a relationship between this wavelength, that is X-ray wavelength, and the atomic number or nuclear charge. And based on that, he resequenced the table based on the atomic charge or atomic number, whatever way you call it. Basically they are same. Atomic charge is same as atomic number, and it is same as the number of protons in the nucleus. So based on his new findings, he resequenced the periodic table, and there was a tremendous advantage which could be drawn from this observation and his new classification. Most of the defects of Mendeleev's periodic table disappeared. Even the Mendeleev's periodic table was great actually, but still it had some of the drawbacks. I am coming to that. For example, now cobalt can be placed before nickel without any hesitation because even though atomic weight of cobalt is more than atomic weight of nickel, but atomic number of cobalt or positive charge in cobalt is less than that of nickel. Actually I typed it wrong, so it should be read that atomic number of cobalt is lower than that of nickel. I wrote it wrong, please correct it. Another disadvantage from Mendeleev's table disappeared now. Placing the isotopes. Isotopes have different atomic weights, so placing them in the same place in the periodic table was difficult according to Mendeleev's periodic classification, Mendeleev's periodic law, because it was based on atomic weight. Now based on atomic number, isotopes can be placed in the same place because they have the same atomic number or same number of nuclear charges, because this whole classification is based on nuclear charges. Now, based on that, Henry Moseley arranged the elements in 7 horizontal rows, which he called as periods, and 18 vertical columns, which he called as groups. You can see the modern periodic table here, but anyway, you can pause the video, you can see it, or I will, in my next few lectures, I will discuss about modern periodic table in detail. Okay, so if you do not want, you do not need to pay too much of attention here. I'll discuss it later. So his classification was 7 horizontal rows called periods and 18 vertical columns called groups, and this actually forms the basis of modern periodic table. Okay, so now we are seeing a shift from atomic weight based classification to atomic number based classification. So modern periodic law states that physical and chemical properties of elements are periodic function of their atomic numbers. That is same as atomic number is nothing but number of positive charge or protons in the nucleus. Hence elements arranged in increasing order of their atomic weight showed similarity in properties. Okay, so when I arrange them in the order of their increasing atomic number, they show a similarity in properties at a regular interval, and that we call as periodicity in properties. Okay, and it recurs at a regular interval. Now we got a very good insight also. Why this periodicity in properties? Why properties are coming back again and again? Now we got a good insight. It gives a good explanation why elements show periodicity in properties. Is because electronic configuration of elements recur after a regular interval, and electronic configuration depends upon electrons are there in their shell because of the positive charge in the nucleus, and electronic configuration recurs at regular interval. So the periodicity in properties is there. That means properties also recur at a regular interval. Properties of elements depends upon their electronic configuration. So elements which are having similar electronic configuration have similar properties. So now everything we are able to understand the moment we understood the structure of the atom, what is there in the nucleus and what is there in the shells, electronic shells. So now let me define some of the periodic properties. One is atomic radius, which is the distance between the center of the nucleus to the outermost shell. Ionization potential, energy needed to remove an electron from the outermost shell. Electron affinity is the energy released when an atom accepts an electron to form a negative ion. Okay, so based on Henry Moseley's observation and his interpretation, now we are able to understand the periodicity in properties. We are able to define some of the periodic properties. Okay, so that is about